Hello. For this example, we're going to be looking at what values of x, this should say, does the power series converge. So again, when we're looking at series, one of the very most fundamental things we can do would be to evaluate what the series would look like, and that would be 0 factorial x to the 0 plus 1 factorial x to the first plus 2 factorial x squared. And this can go on infinitely, but we'd like to list out a couple of terms to kind of really think about the behavior. So x to the 0 is 1, and 0 factorial is 1. Our first term here is 1. 1 factorial is 1, so I have 1x, or just x. 2 factorial is 2 times 1, so I should have plus 2x squared. I don't know why those plus signs weren't showing up. And then 3 factorial, 3 times 2 times 1, we've got 6x cubed. And obviously the terms go on. So we want to know where will this power series converge to the polynomial. And in order to find that convergence, we look at determining the interval, and we're going to do that using the ratio test. And if you recall, the ratio test involves calculating some value rho, and we calculate rho by looking at the limit as n goes to infinity of the absolute value of the nth plus 1 term. I started to write it in there. Let me write a sub n plus 1 over the nth term. So we're going to set this up and calculate rho, and that's going to give me an interval because we're going to want that rho value. In order for it to converge, rho needs to be less than 1, and we'll be able to use that to create an interval and determine where it converges. Okay, so let's do our ratio test. Rho equals the limit as n goes to infinity of my nth plus 1 term, that is n plus 1 factorial times x to the n plus 1. And then that would be over the nth term, which is just the term as it's given, n factorial x to the n. So that's in absolute value bars. Okay, so now what we're going to do, we're going to simplify this expression. One thing that we should already recognize, n plus 1 quantity factorial over n factorial. If we went to list that out, the very first term would be n plus 1, and the next term would be 1 less than that, which is just n, and that would continue. So we have this n factorial over n factorial, which cancels, and this first term is just going to turn into n plus 1. So I have the limit as n goes to infinity, the absolute value of n plus 1. And then what happens when we look at simplifying x to the n plus 1 over x to the n? We can subtract exponents, so that's n plus 1 minus n. We just end up with an x there. Okay, now we're looking at n going to infinity. That means we're not evaluating the limit for x, and that x can come out in front. So we have absolute value of x times the limit as n goes to infinity for the absolute value of n plus 1. And so very clearly we can see absolute value x. That limit, infinity plus 1, is going to turn into infinity. So what this indicates is we have a divergent integral, which means it does not converge anywhere, okay? However, we do want to think about what is going on right here at x. And the only thing, the only term that could possibly create an issue would be x equals 0, right? So we're looking at x equals 0, and we want to think about what is happening there. If x equals 0, we would end up with 0 times infinity, and that is an indeterminate form. So all other values of x, 1 times infinity, 2 times infinity, negative 3 times infinity, they would all give me infinite values. But when I plug in x equals 0, I get an indeterminate form. So we have to consider what our given series up here, what this guy would look like if I were to let x equal 0. So if we let x equal 0, so I'm going to say n factorial x to the n. I'm going to list those terms out. We said it was 1 plus x plus 2 factorial x squared plus 3 factorial x cubed. What do you notice about all of these terms in the polynomial if I let x equal 0? Those would all zero out, and the sum would go to 1. So this is a positive related series, so we would say it converges. I cannot spell today. It converges absolutely. So the series diverges for all values of x except at the one value that would create that indeterminate form, which we can't exactly know what the behavior is, and we would say it converges absolutely there, okay? All of the terms vanish and the series equals 1. Everything was positive. This is absolutely convergent. So it diverges everywhere except for at x equals 0.